Question 16a. John's home is at point A and his school is at point B. A straight river runs nearby. The point on the river closest to A is point C, which is 5 kilometers from A. The point on the river closest to B is point D, which is 7 kilometers from B. The distance from C to D is 9 kilometers. To get some exercise, John cycles from home directly to point E on the river, X kilometers from C, before cycling directly to school at B, as shown in the diagram. The total distance John cycles from home to school is L kilometers. Part 1. Show that L equals the square root of x squared plus 25 plus the square root of 49 plus 9 minus x squared. In triangle EBD, length ED is equal to 9 minus x. Now length L is equal to the sum of length AE and EB. Now triangles ACE and EBD are both right angled triangles, and AE and EB represent the hypotenuse of both of those triangles. So by Pythagoras' theorem, length L is equal to the square root of x squared plus 25 plus the square root of 49 plus 9 minus x squared as required. Part 2. Show that if the first derivative of L with respect to x equals 0, then sine alpha equals sine beta. The following are the marking guidelines for question 16a, part 2. For 1 mark, we have correctly differentiates the square root of x squared plus 25, or equivalent merit. For 2 marks, we have obtains x over the square root of x squared plus 25 is equal to 9 minus x over the square root of 49 plus 9 minus x squared, or equivalent merit. And for 3 marks, we have provides correct solution. Before we differentiate L with respect to x, we need to change the expression for L from surd form into index form. So L equals x squared plus 25 to the power of half plus 49 plus 9 minus x squared to the power of half. Now we can differentiate L with respect to x. So using the chain rule, dl dx is equal to half times x squared plus 25 to the power of negative half multiplied by 2x plus half times 49 plus 9 minus x squared to the power of negative half multiplied by negative 2 times 9 minus x. Next, we'll let dl dx equal 0. Now we can also combine the half and the 2x by multiplying them together. So half times 2x is just equal to x. And we can do the same thing here as well. So half times negative 2 is just equal to negative 1. So x times x squared plus 25 to the power of negative half minus 9 minus x times 49 plus 9 minus x squared to the power of negative half equals 0. So moving this expression here from the left-hand side over to the right-hand side by addition, we have x times x squared plus 25 to the power of negative half is equal to 9 minus x times 49 plus 9 minus x squared to the power of negative half. Now converting this equation back into surd form, we have x over the square root of x squared plus 25 is equal to 9 minus x over the square root of 49 plus 9 minus x squared. Now note that CE is equal to x, ED is equal to 9 minus x, AE is equal to the square root of x squared plus 25, and EB is equal to the square root of 49 plus 9 minus x squared. And recall that AE and EB represent the hypotenuse of the right angled triangles. So from this equation, so replacing the numerators and the denominators with what we have here, we have CE over AE is equal to ED over EB. Now using right angle trigonometry, sine alpha is equal to opposite over hypotenuse, which is equal to CE over AE, and sine beta is equal to ED over EB. And because CE over AE is equal to ED over EB, we have sine alpha is equal to sine beta when dl dx equals 0. Part 3. Find the value of x that makes sine alpha equals sine beta. The following are the marking guidelines for question 16a, part 3. For 1 mark, we have makes some progress, and for 2 marks, we have provides correct solution. From part 2, we've shown that sine alpha is equal to sine beta when dl dx equals 0. This implies that angle alpha equals angle beta. Now, since angle alpha and angle beta are acute angles, then this implies that tan of alpha equals tan of beta. And using right angle trigonometry, we know that tan is the ratio opposite over adjacent. So tan of alpha is equal to x over 5. Tan of beta is equal to 9 minus x over 7. And since tan alpha equals tan beta, this means that x over 5 is equal to 9 minus x over 7. So solving this equation by cross multiplication, we have 7x is equal to 45 minus 5x. Adding 5x to both sides, we get 12x is equal to 45. And then dividing both sides by 12, we have x is equal to 45 over 12, which is equal to 15 over 4, or 3 3/4. Part 4. Explain why this value of x gives a minimum for L. We can use the first derivative to test the nature of the stationary point at x equals 3 3/4. And it's certainly easier to use the first derivative in this case compared to using the second derivative, and also considering that part 4 is only worth 1 mark. So when x equals 3, the value of dl dx is equal to negative 0.136 and so on, which is a negative gradient. And when x equals 4, the value of dl dx is equal to positive 0.0434, which is a positive gradient. So therefore, x equals 3 3/4 gives a minimum value for L. The following is the feedback from the Marking Centre for question 16a. For part 1, in some responses, students found it difficult to respond to the direction show. Some provided an answer which predominantly included the result provided in the question without any clear explanation. Almost all responses used Pythagoras' theorem. However, not all referred to the sides of the given triangles, but instead used the generic a squared plus b squared equals c squared. For part 2, in some responses, students recognized the connection between dl dx equals 0 and sine alpha equals sine beta and were able to set their work out in clear logical steps. In better responses, students expanded 9 minus x squared and then differentiated or identified ratios for sine alpha and sine beta. Common problems were differentiating incorrectly, integrating instead of differentiating, not recognizing the relationship between dl dx equals 0 and sine alpha equals sine beta, and incorrectly expanding 49 plus 9 minus x squared. For part 3, in better responses, students recognized if sine alpha equals sine beta, the triangles were similar. Or if sine alpha equals sine beta, then tan alpha equals tan beta for alpha and beta acute. In most responses, students tried to solve x over the square root of x squared plus 25 equals 9 minus x over the square root of 49 plus 9 minus x squared, and found the algebraic manipulation required to be challenging. Common problems were making algebraic errors when solving the equation, and using x over 5 equals 9 minus x over 7 without explanation. For part 4, in better responses, students responded correctly to the direction explained by demonstrating a deeper engagement. Using a table to test x values above and below x equals 15 over 4 and explain why their x value gave a minimum proved to be the easier method. Students who attempted to find the second derivative and substitute their value for x found that method difficult.